Quantitative literacy. Quantitative arguments are all around us. Whether we read a news blog or shop for an item, quantitative arguments are implemented everywhere to persuade the audience into purchasing the item or believing and supporting a claim. For example, let's look at the Pop Chips advertisement. Within this ad, Pop Chips have been compared to fried chips and kettle-style chips to show that Pop Chips are a healthier choice. Fat, carbs, protein, and fiber count have been compared between the three categories, and the difference is used to persuade consumers into buying this product. Quantitative analysis helps develop ethos, logos, and pathos within an argument. How we present data changes how it appeals to the audience. What is quantitative analysis? In simple words, quantitative analysis is a way of measuring or evaluating items through the examination of mathematical values of variables. Quantitative analysis helps define problems, see alternative point of views, speculate about causes and effects, and create evidence-based arguments. How is quantitative analysis useful? Quantitative analysis provides individuals the skills to reason and solve quantitative problems from a wide range of everyday situations. It gives them the ability to understand and create strong arguments supported by quantitative evidence. By recognizing how writers frame numbers to support the story they want to tell, one understands that other stories are also possible. Ethical use of numbers means that one uses reputable sources and does not invent or intentionally distort numbers for his or her own purposes. Do not ignore alternative points of view. When analyzing data, ask yourself, what do the numbers show? How can the numerical information be used to establish the context or significance of the topic? How can the numbers help describe the topic more precisely? What is the unit of measurement? What was the numeric information compared to? What evidence is there that the measurement procedures are reliable, valid, and otherwise sound for the purpose of the study? What might have influenced the findings? To understand quantitative data and make logical conclusions, you must first familiarize yourself with the basic numeric terms. Maximum and minimum. The maximum number is the highest possible, for instance, 100 on a quiz. The minimum is the lowest possible, for instance, 0 on a quiz. If a student made a 95, that's the highest score, but not the maximum score. Range. Range is the difference between the highest and lowest observations. Subtract the lowest from the highest, the range between 100 and 90 is 10. Mode is the most frequent observation. Here in this example with all these numbers in the parentheses, the mode is 5. Mean is the average of scores, the total of all scores added and then divided by the number of scores. Here, in this example, the mean is 4. Median cuts the observation in half. It is a score that occurs in the middle. Here, in this example, with the numbers in the parentheses, the median is 3. If you have an even number of scores, add the middle 2 and divide it by 2. Here in this example, we can add 4 plus 4 equals 8. 8 divided by 2 equals 4, so the median is 4. Frequency is how often an observation occurs. For instance, how many times did the boy hit the ball? Let's say he hit the ball 20 times out of 100 tries. Relative frequency is expressed in percent. In this case, the frequency is 20 and the relative frequency 20%. Sometimes we know a score or value has increased or decreased, but by how much? By calculating the percent of change, we can determine how much change occurred. Percent of change is all about comparing old to new values. Comparing old values help calculate how much a value has changed. As Math is Fun website explains, the formula to calculate percent of change increase is to subtract the smaller value from the larger value and divide it to the smaller value. Then multiply that number with 100. For example, if there were 200 customers yesterday and 240 today, to calculate percent increase, you will subtract 200 from 240, divide it to 200, and then multiply it with 100. Here we have an 20% increase. But if there were 240 customers yesterday and 200 today, to calculate the percent decrease, you will subtract 240 from 200, divide it to 240, and then multiply it with 100. And the result shown is 16.6% decrease. The mode used to interpret the data can alter the rhetorical effect of a statistic. As the Writing Arguments textbook shares, writers can alter the rhetorical effect of a statistic by choosing between raw numbers and percentages. In the summer of 2002, many American parents panicked over what seemed like an epidemic of child abductions. If you cited the raw numbers of these abductions reported in the national news, this number, although small, could seem scary. But if you computed the actual percentage of American children who were abducted, that percentage was small. Example of quantitative argument. This is a table from the National Centers of Environmental Information. This table shows data for the 16 warmest years from the year 1880 to 2015. Using this informative data, we can make a number of calculations. Looking at the temperature since 1800, we can notice that the last 15 years have been the hottest. Year 2015 has been the warmest year, and 15 of the hottest years have all occurred after 2002. Data shows a consistent and gradual increase in temperature. To calculate the percent of change, we will subtract the lowest rise in temperature documented in this table from the highest rise in temperature. So subtract 0.97 from 1.62, divided by 0.9, and then multiply it with 100 to receive a result of 67% increase. From these calculations, we can conclude that with an increase in the average rise in temperature of 0.97 degrees Fahrenheit in 2008 and 1.62 degrees Fahrenheit in 2015, the temperature rise on average has increased by 67% in the reported 7 years. To calculate range using the same data, we will subtract the lowest temperature from the highest. 1.62 take away 0.97 equals 0.65 degrees Fahrenheit. To calculate mode, we will need the most frequent observation, which in this case is 1.10 degrees Fahrenheit. To calculate median, we will take the temperature that occurs in the middle and cut the observation in half. Here, since we have an even number of scores, we will add the middle two numbers and divide by 2. 1.12 plus 1.10 divided by 2 equals 1.11 degrees Fahrenheit. To calculate mean, we will add all scores and then divide them by number of scores. 18.33 divided by 16 equals 1.14 degrees Fahrenheit. These various representations of the same statistical information will help create different emotional, logical, and ethical appeals. Figure 1 is a visual representation of the data shared in the prior table from the National Centers of Environmental Information. Here you can notice how converting data into a graph makes it easier to visualize and understand the information. Here one can recognize in a glance that 2015 has been the hottest year and 2015 was the second hottest. When creating a chart or graph, make sure it is clearly labeled. What do the X and Y axis represent is clearly shown. And also make sure you credit the source where you gathered the numeric data from. Now, if you were writing a paper on global warming, you can use these numeric findings to support your argument and make it more convincing. Convert your findings and calculations into a paragraph that fits with the rest of your argument. When doing so, make sure you refer to the figure and relate your calculations to it. Calculate and use within your argument at least 2 of the basic numeric terms we discussed. Here in this example, I have added 3 of those terms: range, percent of change, and mean. Your numeric calculations should be accurate and they should present a logical argument. Use other scholarly sources to support your claims. Here I have used Global Climate Report for support. Always cite your sources. Show how your numeric calculations relate to your overall argument. This here is a list of database and open sources that you can use to collect raw data.